Good afternoon, everyone. Welcome to our webinar today, Automation Tools for Bridge Design, put on by ALLPLAN. My name is David Lockery, Business Development Manager for Infrastructure and Public Markets in North America. I have with me Alex Barbone, our Senior Technical Consultant for Bridges and Infrastructure. And we look forward to showing everyone one of the workflows that we've been working on today to enable more automation for what we would consider bread and butter bridge projects. So to start off, put a frame around this, let's consider for a minute current practices. I think everyone on here is familiar with how plans get put together for bridge projects today, or sufficiently simple to the extent that there are simple projects, standard projects. It's fairly common practice for folks to go back to the last project that was pretty similar to this, to recycle some of the information. You consider what they did then in their design approach, but even sometimes to recycle some of the CAD data. Now, obviously, at the simplest end of the spectrum, we've got things like standard details. At the more complex end, we do commonly see engineering teams taking a past project and taking some of the views and the sections that were developed in that project and porting them over to a new one, re-annotating, scrubbing the drawings, and pushing them out as new CAD documentation. That works, hence why it's common practice, but it comes with some big disadvantages. One is on the QA/QC side of things, in that scrubbing those drawings, ensuring that the old annotations, the old documentation, the old notes, anything, the old dimension lines even, have been updated to new dimensions, have been changed according to the nature of the new project. And from what we hear in the industry and some of our experience, that takes very nearly as much time as you save by not having to do the CAD work. So when we set out to build a workflow for these sorts of projects, we thought of this as kind of an inspiration and then sought to utilize the tools that we can offer to enhance that productivity while still allowing a better QA/QC. What does that look like? Well, from a model generation perspective, and just to dial back for 30 seconds, most of the folks on these webinars know what ALLPLAN is. We are a digital delivery for bridges and structures platform, focused on a model-centric workflow that allows you to deliver both BIM documentation and CAD documentation out of the same workflow. No doubling up of your workload, no model over here, CAD docs over there. So from a model generation perspective, what we have done is stitch together the tools that we have, the 2D parametric templates that we have, the 3D parametric templates, the variation tables that enable us to describe how an element's behavior changes along its length over its stationing, and our Smart and Python parts and rebar standards into, dare I say, a universal, not perfectly, but a somewhat universal global template model, which can serve as a starting point for the creation of any bridge that fits into, say, the 2-span, 3-span range. What we do is basically we load this model and we start adding in additional detail. We load this model within a given DOT's workspace with a given DOT's CAD standards, and we start modifying it and adding detail. And by doing so, we've saved ourselves a great amount of time in setting up the structure of the project. We've saved ourselves a great amount of time in loading in template files, in stitching together the variations and the parametric and metadata that actually turn this thing from just a massive 3D solids into a model that knows what it is and knows how you can control it, and allow you to get straight into the business of actually changing this model from a very generic one into a bridge that is your bridge. And then on the flip side, then we have also put together the CAD production standards to say, when I clip a view from this model, when I generate a 2D depiction of this 3D model, it looks like it should. It looks like a bridge, a set of bridge plans that I can push out as a final PDF to a DOT or to a county client. And of course, that takes the same tools that you have in CAD today. Appearance standards regarding levels and line weights and layer structure, fonts, the appearance of dimension lines and leads. It includes title blocks. It includes standardized legends and tables and reporting formats, standard details that function very much the same way they do in CAD, things that are so consistent that we would never consider modeling them as one-offs in BIM. We just slap the standard detail on the page, And ultimately, it also includes the import and export configurations to get these plans into PDF, into DGN, DWG, DXF in the format needed with the appearance needed. So, with no further ado, I'm not going to keep talking. I'm going to turn this over to Alex, who will actually walk us through what this workflow looks like from beginning.
Thanks for that introduction, David. Let's take a look at one of these template projects right now. The one example that we have in front of you is a project that is a two-span precast concrete girder bridge. If we look at our model, we can see that it's pretty plain. There's not a lot of detail in it just yet, but we can still tell the basic bridge configuration from the components that have already been placed. In addition to all of the major bridge components, there are also a number of drawing sheets that have been created already. If I switch to the layout editor, I can see, for instance, one of my general plans. There's actually a whole collection of sheets that have already been created in advance that include some of the basic information that I would expect to see in my package of drawings. For instance, in addition to this general plan, we also have some sheets that are related to the substructure specifically. So I can see my substructure in the three major components, two abutments and the pier. I can see that there's a partial plan for the abutment itself. And there's also an elevation that has some dimensions of the wing wall. So I can see, for instance, that the wing wall is 25 feet from the intersection at the front face with the abutment to the edge of that wing wall. In addition, I also have a sheet that shows the typical cross-section of my bridge. So in this case, I can see that it has 8 precast concrete girders and a deck with a cross slope in either direction. I've got a number of these sheets already, and they basically include what you see here. A few typical sections or views that I would expect to see in all of my bridge packages. I could also add notes if I wanted to, things that would appear on every single drawing package, or maybe it's just a basic outline. Maybe it's all possible notes, and that only requires the designers and the engineers to prune down the list in order to make it specific for the bridge project that they're working on now. The point is that we're going to package up as much of the work as we can early on within this template, and then that way we can rely on the parametric modeling process of ALLPLAN Bridge in order to recreate, tailor the project. And when we come back into ALLPLAN engineering, we're going to see that a lot of our views, sections have updated automatically for us. So let's now take a look at this project within ALLPLAN Bridge. Now the same model that we saw in our project template is open in ALLPLAN Bridge. So again, we can see that same geometry, the two spans, two abutments, center pier, and the precast concrete girders. I can take this generic model and tailor it for the specific project that I'm working on. And I can make all sorts of changes, from global changes such as adjusting the alignment to very fine changes in placing highly detailed components. So let's take a look at a few of those different adjustments that I can make to this project. Let's start with the profile grade line. I'm able to adjust the original axis in order to have it suit the conditions for this specific project. In this case, let's go ahead and adjust the slight curvature in the center of the bridge. We'll reverse the direction and increase its length. I can adjust the vertical profile as well. In this case, let's change the location of the intersection of tangents. We'll move it closer to the abutment 1, and we'll very slightly increase the elevation value there. So now if I switch back to my 3D model, and in this case, let's get a top view of the project. And then after the update, we'll be able to see that the existing bridge geometry follows the new alignment. I can make changes to the second axis that you see at the bottom of the bridge. So this lighter yellow-orange line is the elevation of my bearing stratum. So that makes adjustments for the site conditions and is what sets the bottom elevation of my substructure elements. So the two abutment footings and the pier footing. And adjust that value as well. So in this case, let's move up that value and say that the bearing stratum is at a different elevation. In this case, 3 feet higher than what the generic project had indicated. And now I can see that the pier has shortened because the elevation of the bearing stratum has increased. Now that I've got my new alignments in place, I can go ahead and start adjusting other values for the bridge. For instance, the type of deck that is in use now is a plain deck that has no barriers, sidewalks, or pathways on either side. My model here includes more cross sections than are actually in use on the project right now, and that is because I need to have the ability to switch between a few standard configurations. The current deck is this type here, that's without any parapets or barriers located within its length. But there's a few other options within the project as well. For instance, options with sidewalks on either side, sidewalks on one side, a plain barrier on the other. And then this third option is for a sidewalk on one side and a shared use path on the other, with a barrier separating it from the vehicular traffic. Let's go ahead and switch out which deck type is being used for this project, simply by switching the cross section that's been applied to our deck object. Now when I return to my 3D model and recalculate, now I can see that the appropriate deck type has been selected here. Now this deck type is wider than the previous deck type, and so now consequently I could use some more girders for each of my spans here. Let's hide this temporarily, so that's easier to see the precast concrete girders below. In addition to the variety of deck templates, I also have different cross sections for the various substructure elements. So for instance, in use at the center pier right now is this cap element that has space for 8 girders, then I'm able to switch that out for a different variety that has room for 9 girders. And then I'll be able to add my additional girder to each span. Similarly, for the ends of the bridge, there is different versions for the number of girders for the integral diaphragms. So switching from an 8 girder configuration to a 9 girder configuration. Let's go ahead and switch out the structural members so that I've got room for that additional girder in each span. After recalculation, I can see that the integral diaphragms have increased in width, as has my pier, and now there's space for that 9th girder within each one of these spans. I can add that 9th girder simply by copying one of the other girders in each span to that new location. So now I've been able to switch to an appropriate number of girders for the deck type that I have selected. At this point, I might need to switch out the pier as well. So within this project, I actually have a variety of different types of piers. So the one that you see in use currently is this one that has a plain wall, but I also have additional versions, for instance, where the wall's been replaced with columns. So in this case, I want to switch out the one that's being used for my project to a different one of these templates. And I can do that simply by selecting the member within my project and switching out which template it references. With that in place, I can continue making some more detailed changes to my project. One of the things that I can use is the variations functionality within ALLPLAN Bridge. So these variations are similar to global variables, and what they do is allow us to save a specific value and then call on that throughout the process of modeling the project. So that makes it convenient when you have to enter the same value for multiple different types of members. This allows you to save the value in one place, and then if you need to make updates, update it in one location and have it update multiple members. The other use case is when you have cross-sections whose values vary along their length. So for instance, if I take a look at that deck cross-section we had selected earlier, I can see that it's got very specific cross-slope values on the left-hand side and the right-hand side. So 3% in this case. It's not uncommon for cross slopes to vary along the length of a bridge. In my cross section, I can only set a specific value. However, I can use the variations functionality to apply different values at different locations along the length of the structural members that use that cross section. So if I switch to the variations in this project already, I can see that there's already a value for the deck cross slope on the left and the right hand side. These don't store single values, but a table of values. The graph that you see at the top is just a way to visually represent the same information that is below in the table, and that's where I can make changes. In this case, since I've added a curve to the bridge, I can adjust the cross slope to account for super elevation. So in this case, what I can do is adjust the cross slope, and now I've set values for 1 near the midspan of the bridge, and we'll make that same change as well on the right hand side of the deck. So in this case, I'm increasing the value by -2 or subtracting 2, and that's going to account for the super elevation that we see in that curve towards the right hand side. I can assign these values simply by dragging and dropping them into the appropriate structural member. See that I've already got a location where the cross slope of the deck is calculated at every location along the deck structural member. And I can simply drag and drop the variation into that member. And now we can see that the value is being calculated at different locations. And this is aligning with the table that I had just entered values into moments ago. So we can see the value of 3 near the ends, decreasing to 1 and changing back to 3. And it'll interpolate the values in between. We'll apply the right-hand side. Now when we return to our 3D model and recalculate, the deck will now use the appropriate cross-section or cross-slope values along its length. I can also view that in more detail if I would like. So I can see along the length of the bridge, near the location of that prominent curve, the deck cross slope values are changing. I can also use variations to store values such as the skew of this pier member. For instance, if I need to introduce a skew at this pier, so let's increase this value to 15%. And before we recalculate, let's go ahead and hide the deck again. So now I can see that I can easily introduce a skew for my pier elements, and my girder elements have updated automatically to account for the different bearing location that each one of these has as a result of that skew. I can see my pier object has rotated as well. I can also store values for, in this case, different dimensions for the abutments. So for instance, I can increase the angle of the abutment wing walls with relation to the front face there, and even increase the length of the abutment as well. And we will see this update the various geometric dimensions for each one of these wing walls. So in this case, what I'm going to do is I'll set the wing walls for the first abutments to increase slightly in length, and we'll change the wing walls at the second abutment so that the wing walls are actually perpendicular to the front face. So now I can see that I've quickly managed to tailor the wing wall configuration to suit the site conditions for this specific project. I can also include some more detailed components. For instance, I know that I need bearings for the precast girders at midspan. I can use the automated Python parts or apps in order to take a parametric component and place it at multiple locations within my project. So in this case, for the cross section, that's used to set the bearing location for these girders. I've already placed the Python parts for those bearings. So the type of bearing here is going to be a cylindrical bearing, and I'm able to update the values as well in order to tailor it for each specific bearing. Or I can set all of these values to be the same for each one of the bearings, and then be able to update them automatically anytime that I need to. In this case, I'm going to accept the initial values that have already been created. Now I'm going to turn on the Python parts for that structural member. So in this case, I simply need to indicate where along that structural member those bearings should be placed. So now I can see the bearing objects within my project. There's other Python parts that we can include as well, and these include things that will place reinforcement for us. So for instance, for this project, I am using a specific type of precast concrete beams, and in this case, I can switch them out for a different cross section that already has the Python part located within it. So the original precast girders that we see here are going to be an AASHTO type 5, but let's switch it to a Northeast Bold T 63. Similar to the bearing seat locations, I can see that I've got another Python part placed here. This one includes much more different parameters, and all of these are going to set the reinforcement that is available for our object. Within my 3D model, I can simply switch out which one of the, in this case, link girder templates are used for each one of these girders. So if I were to select any of these girders, I can see that they're all based off of an AASHTO I-beam type 5. So what I'm going to do is I'll select all of the girders, and I'll switch them to use the other reference template, just based off the northeast bulb T. And then I can recalculate. So now I've switched out which cross section I'm using, and now I have included the Python part for that reinforcement placement for each one of my 18 girders. So 9 girders for the 2 spans. So I cannot see the reinforcement within the ALLPLAN Bridge project, but when I synchronize the changes that I've made here with my ALLPLAN Engineering project, I will be able to see that reinforcement. So at this point, I am done making at least the first round of changes in order to tailor the generic model to the conditions of and the design requirements for the project that I'm working on now. So at this point, let's now switch back to ALLPLAN Engineering, and we'll import the changes that we've made, and we'll see what effects it's had on both our model and our drawings. So now we're back in ALLPLAN Engineering, and let's go ahead and switch to the modeling task. We haven't yet synchronized the changes, so we still see the previous generic model. But let's go ahead and update our bridge data so that we can see the new changes that we have just made. Now that we've finished updating it, we can see that the new geometry has been brought into our project. So we can see, for instance, the deck type has changed out. We can see the new dimensions and configuration for the abutment wing walls, and of course that the pier type and skew angle has been adjusted. We can see the Python parts that we had placed for those bearings as well. If we adjust the visual settings for some of the objects here, so in this case, let's change the transparency for our 3D objects, and we can see that there is now reinforcement within the project. So this reinforcement was added automatically based off of the values that we had specified earlier within ALLPLAN Bridge for how these reinforcement bars should be parametrically located. And we can see that all of the girders have now been reinforced. This at least includes the bulk of the reinforcement. However, there might be some modifications or additional reinforcement that might be required, especially around the ends of the girders to account for things like jacking forces. But we've managed to place a large quantity of it already relatively quickly. Now let's take a look at how our sheets appear and take a look at some of those views we created to see how that they have updated. So I can see now that my typical section through my deck has updated, and I can see the correct number of precast concrete girders and the correct deck configuration. So before this showed only the 8 precast girders, and now I can see the deck, the barrier, and the sidewalk as well. Let's take a look at a few of the other sheets. My general plan has been updated, so I can see the new configuration. I can clearly identify the location of the sidewalk, the shared use walkway, and the wing wall locations have also updated with respect to the abutment. The substructure plan as well has updated, so I can see the new plan that shows the location and configuration of the abutments. I can even see that my pier object has updated, so I can see the hidden line values for the columns below, and I can even see the location of all of my bearings. Even the elevation of the wing wall has updated, and in this case I can even see the new dimension for the wing wall, which we had changed from 25 feet in length to 30. So even some of the dimensions that I had placed previously These associative dimensions have updated to show the accurate lengths of the different members that have become updated. So I can continue making changes and working to advance my project, but we can see that by setting up a template project beforehand and using them for similar bridges, I'm able to cut a lot of the process out of each individual project that I work on afterwards. So by investing the time within that project templates for different configurations of bridges, I can quickly tailor them for a specific bridge project. And I can even include a variety of different resources within each template so that I can quickly switch between several standard items such as precast concrete girders, types of piers, and the deck configuration. And then of course I still have the same ability I always had with the parametric modeling process for tailoring the objects as I go. So in this case, we can start the project a little closer to, say, 10 or 15% of the design simply by relying on work that we have already done. You can get started with these project templates simply by beginning to compile all of the different resources you have created for your variety of projects and start placing them all in one centralized location. From there, it's a simple matter of creating a few generic projects for the different bridge types that your organization routinely designs, and then tailoring them again for each specific project thereafter.
Well said, Alex. As you can see, the goal here is to take some inspiration from the way we've always done this, the way we've tried to achieve some level of automation on these sorts of projects while still providing greater flexibility, providing greater enhancements to QA/QC, and ultimately improving plan quality. And with that, we're going to leave it here and open the floor for Q&A. If anyone has any questions, we do have a list of them in the team chat, but if you have any additional ones, please drop them in and we'll do our best to answer everything. Thank you so much for your time, and we look forward to hearing what you think.
Everyone can hear me. I apologize. But the question that was asked was, how do we do QA/QC on a model-based project? And we have a couple of ways of dealing with that. One is that because we are still producing 2D documents out of these models in the future, we QA/QC them the old-fashioned way. And especially once you come to trust that the map accurately represents the terrain, so to speak, that the drawings accurately represent the model and vice versa, you can QA/QC the entire model simply by going through drawings. In addition to that, though, we also have some workflows and some automated tools to allow us to do it. So as to improve the quality control. So we have the ability to flash detections between different sets of elements or different individual elements up to and including rebar checks for flashes for clear cover. The goal is to produce plans that are going to be more constructible the second you get to site would otherwise be the case. In addition, we also have tools that are aimed more at the future of digital delivery, the ability to automatically check that all of the elements, all of the individual objects within a model have all of the attribute data, metadata that's supposed to be for a given DOT's digital delivery standards. All right. Then one other technical question, which is, how do we handle producing drawings of curved bridges? So I assume this is referring to elevation views of the center line of the bridge deck. And we have tools that allow us to capture that center line and essentially press it flat into a page to produce the same, what we would call developed views that have no perspective effects as you would be doing in ordinary CAD drawings. So I hope that answers that question. And then the final question is just whether or not we're going to be able to issue some certificates for this. I assume for continuing education credit hours, the answer is yes. We have something that we can get over to anyone who's interested. And obviously we are ending quite a bit early, so thank you all for your attendance. Again, please feel free to contact us with any questions. We'll let everyone get back to their day now. Thank you very much.